Right, good morning then. I'm Dave White. I'm from Babcock. Sat on my right here is Harry. He's from CAC. We've got Ashley and Andy Farmer's actually at the end there, and Chris Cooper from NHB, second from your left. Okay, so over to Chris.
So what we'd like to talk about this morning is the forthcoming helicopter safety awareness courses. These are going to be presented throughout the UK at various dates and times. And we're going to cover three main topics on the courses. We're going to cover flight operations and passenger handling, and then some information about how we engineer the aircraft. Just for a little bit of background into the industry, there's some stats that have just come up on the screen. Quite interesting, in 2017, there was nearly 1 million people that were transported offshore. So as you can see, there's a lot of movement between the four companies, and it's quite an involved industry. Andy's now going to talk to you a little bit about the day in the life of a helicopter, and these are some of the subjects and topics that we're going to talk about during the courses when you come to the various sites.
Ladies and gentlemen, good morning. So, day in the life of a helicopter, this is primarily really how you would see it before it takes you or your workers offshore. So, if you look down at the bottom right, around about the 5 o'clock of this circle, pre-flight inspection. So, aircraft is inspected every morning before it goes out. So we have it inspected, and then this is verified and checked with a second engineer to make sure that the first engineer has checked everything correctly. A lot of these activities go on concurrently, so there's a fuel inspection, and at that stage the pilots are planning. Once they've conducted their plan, they then do the walk around of the aircraft, and they then have a visual check just to make sure everything's okay, just in case anything has been missed. Preflight checks, including the starter, the aircraft's then cleared to enter service, and this is really a crew commitment to say that they're happy to take the aircraft. We routinely fly a couple of flights a day as a single crew, so that turnaround inspection by the engineers is that check in between just to make sure that everything is okay. Then eventually at the back end of the flying day, it's again inspected, washed, any reports are reported, and that report comes from either pilots where they've been flying during the day or from the engineers once they've done the post-inspection. There's also the time then when any long-term maintenance, so inspection of components, inspection of the aircraft again, and then finally the after-flight inspection. You can see there's a whole myriad of checks and safety systems in place just to make sure that that aircraft is fit for purpose. Okay, you can see there everything is underpinned by safety. We essentially sit under the Department for Transport. The Department for Transport covers everything up to and including 747s transiting over to America, and the buses or the taxis taking you across to where you're going on a night out. We sit under that, under the Department of Transport, inside the remit of the CAA. The Health and Safety Executive have the overarching responsibility to make sure that everything's safe and conducted, and that your health is not compromised in any way. For us, primarily though, working under Oil and Gas UK, and you can see the Step Change in Safety Group. Now, Step Change in Safety Group, they're there to promote, as I'm sure you're aware, the safety aspects of the offshore industry, but it also provides an opportunity for us here as a group of collaborative operators. So we're all separate commercial entities, but we're all aviators operating in the same airspace. So we share absolutely everything in terms of making sure that we're doing things correctly and operating with the best practice. From our perspective as a chief pilots, we talk regularly on the phone just to make sure that if a good idea is useful, then we can share it across all four business units. Oil and Gas UK, as I said, they are primarily responsible for disseminating that information through Step Change. And also to your far right there, you'll see the HCA, which is the Helicopter Certification Agency. The Aviation Safety Technical Group right down at the bottom there, that again is a CAA-generated organisation, or sorry, CAA-run organisation, which makes sure, again, that everything is operated safely. So you can see everything is underpinned by safety, best practice and best procedures. So it's incredibly comforting to be under that umbrella.
Good afternoon. I'm going to touch basically on pilot training. Traditionally, you probably find that the majority of pilots in the North Sea have come from a military background. Though you'd probably be surprised to know that about 50% is split between civilians and military pilots these days. From the military perspective, you would have gone through a specialist aircrew selection process, which is quite an involved selection process. But once you've finished a military career and you wish to enter into civilian lifestyle, then we now have to meet all the same criteria as civilian pilots in terms of completing all the licensing requirements from written examinations, instrument ratings, and type ratings. For those who are following a purely civilian course, you can follow an integrated course, which is effectively a dedicated flight school, or you can go through a modular route, which takes a little bit longer, but it's probably a more affordable route for most people to follow, and it's essentially a part-time learning scheme. But at the end of the day, we all end up at the same level in terms of our licensing and our qualifications. To operate on the North Sea, we have to meet a minimum criteria of instrument rating and need to be dual engine rated on helicopter type. The selection process to join one of the companies on the North Sea is fairly involved. We have to pass formal interviews, pass simulator assessments, and then before continuing on to our employment, complete type rating, whether that be the 92, the 189, 175. The type conversion take about 3 weeks. The line training can take minimum about 4 weeks, but that's obviously subject to operational requirements on the North Sea at the time. At the end of the day, we'll all qualify as line pilots, and then we can follow a progression from first officer through to getting your command. It takes about 4 years for it to complete.
Right, the training on the aircraft is not the only thing we need to do. A large part of what we do is human factors, how to interact with the other pilot in the aircraft, with your ground staff, with your management, and everybody around you involved in the flying. In order to keep that going, we have crew resource management training, which is mandatory once every year. And this evolves nowadays in team resource management training. It's not just for the aircrew, the pilots in the aircraft, it's for everybody who works at the helicopter company. We talk about things like airmanship, communication, how to bring your ideas across, how to speak up for yourself if you see something that is leading to a potential unsafety. And it is a good way of learning all those skills to take them forward in your further career. It focuses on all kinds of behavioral aspects, so decision making, the standard safety, and all the non-technical skills that are involved in simulator training as well, which can revolve around decision making, cooperation, leadership, but also followership is a good part of that. And this happens, once every year, like I said.
Okay, moving on then. So, RTBs, or return to bases. What are they? I'm sure you've got some questions maybe as well. But primarily, though, we have a minor problem with the aircraft. Sometimes precautionary RTBs as well. But basically, what you need to understand is that the aircraft is still serviceable. But ultimately, what we don't want to do is to end up on a rig and potentially having to shut down and closing that heli deck off. All right, so we have various levels of emergencies within the aircraft. But like I say, so RTBs we will generally return to base. But like I say, as a precautionary measure.
So we just talked about touched on engineering there. One of the things that you may have heard of over recent years is HUMS, which is the Helicopter Usage Monitoring System. All our flights are monitored, so the aircraft has lots of sensors. And in between each flight, that means even if the aircraft is running, so sometimes the aircraft running when they come back to base, we have a data card, and that's given to the engineers on every single trip. So that's downloaded, and that can see a lot of the stuff that we can't see in the cockpit. So our engineers can actually see if there is something that maybe is changing in the aircraft. And this has been a giant leap forward in terms of our engineering safety. But it's not just engineering safety, we also have monitoring for us as pilots as well. So we have a system called Flight Data Monitoring, which is FDM. Some people would call us the spy in the cockpit, but it doesn't work like that. It's very confidential, and it's all part of our safety process. But there are certain sensors in the aircraft, and at the end of each day, or at the end of some of the flights, some of this data is downloaded. In fact, all the data is downloaded. And one of our FDM analysts can look through that flight. It's not to trap us, it's not to punish us, but if there's a trend developing, for example, if one of our rates of descent on an approach is too high, then we can trap that at an early stage. Before, we wouldn't have known this until we've gone to the simulator, but now we can see this across a whole fleet. And also between the companies, a lot of the FDM data is shared because it may be specific to an aircraft type, so the S92 or the 175 may develop a trend. So this is something that's been brought in. It's done by all the airlines, and it's now a requirement under what's called the Helicopter Offshore Flight Operations, part of our regulations to have this. Andy, you can talk a bit about the weather.
Cheers, Chris. Okay, so weather. Weather is by far the biggest variable that we have to deal with as helicopter operators, and for you as clients, it can be incredibly frustrating. So to give you an example of some of the products that we use there, the screen that you've got in front of you now is showing you what is called the Met Office OH Web, so Offshore Helicopter Web Service. And this is basically our legal means for checking the weather, both onshore and offshore, and it gives us indications of what we're looking at in terms of general weather pictures, and just making sure that what we've seen or what we're expecting tallies up with a picture that we can present then and do our planning on. The next slide, if you look at, this is what is part of a pre-designated pack which we take with us in the aircraft. Although all the information you can see on the right there may appear very confusing, once you get used to it, actually it's very useful. And that gives us a very good breakdown of the areas that we're looking at in terms of weather. So you can see, for example, you've got areas A, B, and C, and they all have their own definitive or bespoke weather conditions on that day. This then allows us to look at the weather conditions so that we can safely know that we can route to an offshore installation and go somewhere should we not be able to get in due to bad weather offshore. And it allows us to conduct that planning to make sure that we offer the best payload, but also the safest option for everybody concerned. Okay, when it comes to weather planning, this does provoke a bit of debate between crews as to what they plan the weather on in terms of the wind. So we'd like to offer as much we can in terms of payload. However, some of you will be aware of the wind speeds up here in the north of Scotland can reach speeds in excess of 70 knots up at altitude. And that, of course, plays a massive instance or a massive issue for us in terms of a comfort, but also what we can offer you. If you're leaning into 70 knots of headwind, it's going to take you a lot longer to get there, which is going to increase your fuel burn. So for us, it's not a standard, we're going out to a certain installation. It's a variable that changes every day and sometimes several times a day. This is an example of the offshore helicopter weather. So before we lift from any of our bases, we check the weather. And the things that we're looking for are the weather conditions. So again, we can plan for the safest option. So do we need to include more fuel for an approach? Is it likely that we can get in with the weather in the conditions that we've got? And most of these systems are now automated. So there's very little operator input from most of the installations offshore. With these being automated, there is a margin for error. However, they are quite accurate. So we're very rarely surprised by the weather when we get offshore. This is a standard format that all operators use. So whether you're Babcock, NHV, CHC, or Bristow's, we're all using exactly the same format, and we're all conforming to exactly the same rules. And again, it's the safest option in terms of what we have presented to us to what we plan and give you as the clients. However, triggered lightning. Many of you will have heard of triggered lightning. It's a phenomenon it's a weather condition which affects us and Japan. And if you look on the picture there, that gives a very good idea as to what is effectively an hourly changing picture. For us as operators, we have very strict rules, as in the areas that are annotated in the red, we're not allowed to fly in. Unfortunately, those areas change from hour to hour. So we may have a plan which we base on a certain time to lift in the morning, and we say we're okay, that's absolutely fine. And then that picture will change to represent nothing that it looks like before. The frustration for us as a crew is that we can't make our takeoff times and we can't get out to the installations, but also for you as the passengers, because when we present you with a picture and a plan which is safe, which is viable, then the system changes, and of course we have to take that into consideration. One of the biggest frustrating factors, however, as a quorum or as a group of operators, we have found ways to mitigate or to use the tool, the planning tool, as safely as we can, and we're all signed up to doing whatever is best practice when it comes to triggered lightning.
Part of the future courses is engineering as well. We divided between part 145 and part M, the line engineering and the continuing airworthiness. Just as the pilots, the engineers go through rigorous selection and training before they start at a company. They have a basic course and then they enter a company as a non-licensed engineer. They need to build up experience or maintain the aircraft before they can then become a license in either avionics or the heavy engineering, the mechanical side of it. Without them, basically all the flying would stop. So whilst we are the front end that you see, the engineers do the hard work of keeping the aircraft airworthy. Part of what goes in there is the maintenance of some systems that we use to keep the aircraft safely in the air. We've got a system called TCAS, Traffic Collision Avoidance System, and this tells us where all the other aircraft that carry transponders, a radio beacon that signals out its whereabouts to ground stations and other aircraft. So when they come closer to us, we can see the symbology change. We can see if there are aircraft affecting us in flight path and in altitude, and the system can tell us how to separate from them. It has meant an increase in safety because, as you can imagine, if we fly in clouds, the visual lookout for other aircraft is not really a viable option, and that's where, in combination with the air traffic services, the TCAS comes in handy. Another element there to improve the safety is something called EGIP-WIS, or Enhanced Ground Proximity Warning System. This has got a digitized map of the terrain and of the highest elevations around. It gives us warning if we get too close to the terrain without being in the proper configuration. So if we come in for landing and the landing gear is still up, the system warns us for that. If we come too close to high obstacles, the system warns us for that. And it just improves our general situational awareness. On the ground side of this, there is satellite tracking. All the helicopters in the North Sea are not only being tracked by air traffic control and radars, but they send out a signal to satellites as well, and this gets monitored in all the different operators. So any operator can see where any of their aircraft is at any given time, can see if they have a return to base issue, or when they expect them to land on a rig or expect them to land back at home.
Okay, safety and quality, I think it's fair to say that underpins everything we do, and it has to. So when you're tying it all together, this is something fairly new to us as operators, but your bow tie system, effectively the ownership of the barrier, we appreciate that we've got to play our part in that as well. Your daily safety review meetings, we as operators have the same. So as Chris alluded to earlier, for identifying trends or for identifying issues, then that's something that we're able now with the technology we get to flag up fairly quickly. And it's something that with a simple email we can inform crews and check is being done. Operational review boards, for us primarily that's the CAA and the OEM's participation. Just making sure that we're following best practice as a collective bunch of aviators and actually as companies, our own individual companies. We're required to do our own audits, both internal and external, and we both can and do conduct our own internal and external investigations. Our safety management system reviewed quite stringently to make sure that actually is it fit for purpose. And occasionally we make changes, which we have to, sometimes to cope with the changes in technology or the changes in condition. Wellness and well-being, it's not all about the technical element, it's not all about the legislative element, it's about how we look after our crews. Are they okay? Are they fit for purpose as well? So there's a certain amount of pastoral care as well as just the basic technical elements of the job and my colleague here, Harry, is actually very well versed in some of these practices, which we're hoping to be going to be rolled out across the aviation industry for us. Some of the safety management systems that we use, or sorry, underpin on the next slide, please. So some of the safety management systems, for us, particularly as aviators, we have the air safety report, whereby we identify any air safety issues that we think can either help other people or help other crews, or actually something where we identify practices that we can change. Ground occurrence reports, these are reports which we can generate by both air crew and ground crew for any issues on the ground. So we cover the whole safety remit from being in the air and the taxiing elements, or even the movement of aircraft on the ground. Again, also accompanied with a ground handling report. Flight crew reports and the use of, as Chris alluded to, the HUMS, the health usage monitoring system, and the flight data monitoring system basically give us what we think is not an all-encompassing, but about as good as we can get with the technology we've got today, of reviewing our own safety systems and making sure that they are fit for purpose. Because ultimately, it's about making sure that everybody's happy with the products we provide. Dave.
Right. I think that pretty much wraps it up there. Onto the question answering.
Yeah, we have several questions coming in. So the first question is, you touched on triggered lightning, but what actually is it? At this point, if only you had a diagram.
We did have a diagram. Sorry, I did a very, very poor job of explaining that. It's basically, I was thinking, don't swear. So triggered lightning. Triggered lightning is a phenomenon where you have what is called a positively charged air mass. That positively charged air mass sits within a certain temperature band. We've got it 0 to +2 -2 degrees. And effectively, it's the helicopters have the blades, sorry, helicopters have the rotating blades on the top. They create a certain amount of friction when they contact with the air. When flying in clouds inside that air mass, there is a potential that that excitation or that movement of the blade can cause a lightning strike to be initiated. And that lightning strike will strike the nearest structure, which in this instance could be the helicopter. So when we have these red planning circles, that is areas that an algorithm which is worked out by the Met Office has identified as being potential areas where that phenomenon can exist. All of us as operators have had, be it here or in Norway, instances where triggered lightning has caused a problem, and there have been lightning strikes. The only real issue with the planning cycle, or the planning tool that we see, or you saw a snapshot of the screen, is it's very variable. But as far as we're concerned, that means that the triggered lightning could be anywhere in and around the North Sea. It means that triggered lightning is present. So crews will pretty much in the winter months, and the period is October through to March, crews will try their best to avoid those areas where it's predicted. But they've also got a healthy awareness that that model can change at any time. So we do our best to make sure that we're nowhere near any of those red blobs when that happens.
And to add to that, the aircraft are designed to withstand a lightning strike and take the passengers home safely. However, one of the reasons we try to avoid it is prohibitively expensive to repair the helicopter afterwards. It scares not only the passengers, but it does scare us as well if we get a lightning strike.
So the phrase "the helicopter has gone technical" is often bandied about in the offshore industry, but it doesn't really instill confidence in the platform crew. Could the helicopter companies explain exactly what has gone wrong with the helicopter as it happens?
Do you want me to cover that? So when we say the helicopter has gone technical, for us, that could, for example, mean something on startup. So it could just be a simple failure of a system. The helicopters are incredibly complicated bits of machinery, a little bit like your installations offshore. And I'm sure the installations offshore are not faultless, and there's sometimes something goes wrong. And so when we identify something like that, we then report it back to the engineers. We, as companies, we'd all be telling you lies if we said these aircraft are perfect all the time. But we have all these barriers in place so that we don't take one of these unserviceable aircraft into the air. This is no different to the airlines. You'll quite often, if you take a flight somewhere, you might find that your airliner has gone technical, as the expression is, or what we call unserviceable. The airlines probably will give you a load of other excuses why that's happened. But for us, we're upfront and honest. All the companies are the same, and we tell our customers when something's gone wrong. So it really is a good thing, although, you know, if you're trapped offshore, and I've worked offshore as well, so I know what it's like when it's the day to come home, but it's a good thing that this actually happens. It's a barrier there for your safety and for our safety, because we have to remember that our guys and girls are sat at the front with you, and we have the same concerns and worries as just anyone else does. So if an aircraft has gone, yes, we've found something, or the engineers have found something that they're not happy with, then the operation stops. Everybody and all the companies have a stop work authority, so anyone at any stage can say, no, we're not doing this. And that's what it is. It's inconvenient. They're complicated bits of machinery. Things do go wrong. Things, despite every part of the prevention, you know, the bow tie, the barriers that we put in, sometimes it's not foreseen. But we trap that error, and we trap that error wherever we can, and hopefully that should be a reassurance to you as our passengers that we're not going to put you in an aircraft that does have an inherent fault.
We're not trying to be vague when we say something's gone wrong.
Yeah.
We just might not know at that time, but obviously you need to know why you're delayed. So we'll say, yeah, the aircraft's it's gone technical, but we're investigating. We might not know exactly what's wrong at the time. So we're not being deliberately vague, but we obviously need to tell you that something's gone wrong.
And some of these issues can be solved quite quickly as well. Yes. We may have, for example, an issue on start with an autopilot. The autopilot, most of the systems on our modern aircraft self-test. So when we're out there starting the aircraft, they run through lots of self-tests. And an autopilot, for example, can fail part of its self-test. It might be that we just need to shut the aircraft down and repower it. They are a very electrical driven aircraft these days, very electronic, and it's almost a control out delete on them. So, but when we first get that issue, as Dave says, we might not actually know what the outcome is going to be. It might be something more serious, which is why sometimes you might find that the information is slow to come. And it's not that we're hiding anything from you. And in the background, as chief pilots, we all get involved with the customers, so you guys, and every time there is an incident, or incident's the wrong word, every time there is an occurrence, so for example, an aircraft goes technical on start, your companies will want to know exactly what that is, and that's followed up in a report from all of us. And there may be an aircrew report, but generally an engineering report that answers that all. So as Dave said, it's not a case of hiding anything, it's just a case of timing.
Yeah, and once we do find out what it is, we will come and brief the passengers on what the actual issue with the aircraft would be. Don't forget that most systems in the aircraft are double or triple redundant. And if even one of those systems fail, the aircraft would still be perfectly safe to fly, but we are in the minimal risk work. So we will take the aircraft back to the engineers to make sure all the backup systems are working as well.
And it was a point that was alluded to by, I believe it was Chris earlier, that quite often on a clear sunny day there'll be an issue with the aircraft that, in all honesty, the aircraft is 100% serviceable. But it may mean if we land, then that the aircraft has to be consulted or looked at by engineering for no other reason than we have a minimum equipment list or a minimum list which states that the aircraft must have. And quite often, in fact, in almost all circumstances, a crew will take well, it's better to be safe than sorry route back to the field and get the qualified engineers to have a look at the aircraft. Safest option every time.
Are there any other factors impact on flight schedules, like wave height, especially for installations located at significant distances from the base?
Yes. It's a short answer. Once the sea is above 6 meters wave height, which is the height the systems for a safe water landing have been tested to, we cannot fly over this. So if the installation or the area in between reports wave heights of more than 6 meters, we cannot go to that location. We may be able to find a way around where the waves are less than 6 meters, but in general it will mean a delay to your flight.
I think there's other thing as well is that we haven't mentioned. A lot of your installations move. They're not tied to the sea, the surface. So for example, on that weather package that we saw, we get an indication as to the pitch and roll and heave of the vessel that we're going to. And there's limits for that, and it depends what aircraft you're flying, it depends on the category of the aircraft, and it depends on the category of the vessel as well. So that all has to be taken into account. And those systems do take, there's like a 20-minute cycle on pitch, roll and heave, and heave rate. So the installations, particularly in the Atlantic, we get huge swells, and that can change. And sometimes we're just waiting for installations to come back into limits. And we do have prediction tools for this, but it's the weather, so we find it difficult to control.
Questions come in. Is there a minimum temperature that helicopters can fly in?
There is a minimum temperature, but we've never met it yet in Aberdeen. Some aircraft or different aircraft that are operated 189, 175 and 92 have different minimum temperatures, but we don't encounter them because they're sort of in the region of minus 37, minus 32. So luckily it's not that cold yet.
And that's what the aircraft is certified for, but the issue is perhaps he's alluding to there is the icing.
Yeah.
So obviously below 0 degrees, then we're going to start accreting ice, and different aircraft have different ways of dealing with ice accretion. But in terms of what the aircraft is certified for, it's low. We never meet it here in Aberdeen.
Why do the helicopters fly so high? In the event of an incident, flying lower would surely increase survival rate.
Not necessarily true. If we fly high, we have a longer time to set up an emergency profile landing. It gives us a wider area to look for a safe landing area. And the other side of it is, the lower we fly to the sea, the more salt we get into the engines, the shorter the lifetime of the engines is going to be. Even though we wash them every day, the salt will have an impact on that. So it's a combination of, at height, I've got more time to decide where I'm going to land in case of any emergency. It's better for the engines. And the other thing we do is we look at the most favorable winds as well to get you to your destination as quickly as we can.
You also do it for a comfort reason as well during the summer. I mean, most aircraft these days have air conditioning. Some of it's more effective than others, I'm sure you're aware, when you've got 3 layers on immersion suits. Last year we had an incredible summer here. So quite often we'll fly at height just to cool the aircraft down. It can be as simple as that. We may do it because it's very turbulent down at lower levels, and if we're sitting in cloud and everyone's getting bounced around, we'll climb and get above it just for everybody's comfort. And during the winter it's always nice to see the sunshine as well.
So I've got lots and lots of questions coming in now. There's one about the survival training. Do you think the current survival training course is relevant to a real-life ditching scenario?
There's been a lot of thought gone into that kind of training. You'd have to say yes, based on previous survival situations. Is it sufficient? It has to be sufficient. I'm pretty sure it is.
I think there's a fine line between, if you, a lot of us, I think, sat around the table are ex-military. The military system is probably, what's the word I'm looking for, slightly more aggressive in terms of dunker training. The water is considerably colder. There's a lot more stress put on you. And I think it would be the wrong thing to do to introduce that into the civilian sphere, because we would just frighten people. And not just passengers, it frightens the crews. I mean, there's lots of us around here that are not hugely keen on doing dunker. We do it every 3 years. So is it realistic? Yeah, it's as realistic, I think, as it can be. And I think there's quite a lot of improvements now because there's waves and there's rain and wind generated at some of the providers. So, yes. But I think it's a fine line between being realistic and overly realistic.
And a lot of it's muscle memory as well. So you've got to wait for a violent motion, then orientate, and then release. So it's muscle memory.
The role of the passenger is obviously important to the overall safety of the aircraft and the flight. And so with that in mind, is there anything that you would request of the oil and gas industry in which we could do better as passengers?
I think actually the way that we conduct the flights and the briefings that you receive are fairly good for purpose, either fit for purpose, and you explain, what your role is, and you're given a refresher training and everything else just before you fly. But I think it's important to remember that the aircraft captain or the crew, But generally, they get checked on this once every 6 months, and it's something that is ever present. Nobody is planning on having a bad day, but it's something that we're trained for. So I think it's just so long as you need to accept that whilst the aircraft captain and the crew are responsible for flying the aircraft, and you rely on them to do that, then rely on them and follow their direction should any emergency situation comes into play. And I think that's the key thing: is don't do anything different than you would be expected to do. Stick to how you would normally operate, and just follow the guidance of the crew. That would be my real recommendation.
We also offer our passengers the opportunity to come forward and speak to us as the aircraft is in a safe configuration. If anybody does have any problems, any issues, or sees anything that they're not happy with, we do welcome that, and we offer that in all our briefs.
I'm going to merge two questions into one. I'll comment on a question. Every time I board a helicopter, I have a superstition of touching the ground first. This has ensured in 14 years I've had a relatively incident-free offshore career. Whilst I appreciate your pilots and engineers are highly trained, can I get a certificate for my commitment to helicopter safety? And do you, as helicopter operators, accommodate for superstitions with passengers? Preferring particular seats and doing particular routines before board.
I don't know, but
that's a really good question.
I think I think probably our ground staff might take it by surprise if someone does the poke moment and kisses the tarmac. But I can't think of any other reason why we'd want to prevent it.
No,
but we don't. We tend to not. We tend to, in terms of the seating. We don't have allocated seats. We don't have tickets. So within reason, and certainly some of the aircraft, we have to put people in certain seats, i.e. we need to move the centre of gravity around, so we need to have people sit further forward depending on our payloads. Other aircraft, it's not as important. So in terms of choosing a seat, I think you just have to get yourself in the right place in the queue as you go out.
I think as well, it's somebody, I come from the military, and somebody said to me that for the offshore industry guys, for travelling offshore, the actual trip on the helicopter can be the worst part of their rotation. So if you've got a ritual which is not likely to affect the aircraft or affect any of your co-passengers, I'd say carry on and do it. If nobody's brought it to your attention, then nothing's really that bad.
Linked to that, I guess, are deck crew asked to position larger people away from windows?
No, there are certain seats for the extra broad passengers. They are designated in all types of helicopters. So if there is somebody with an extra broad armband on, they will be put in those seats. But other than that, there is no special requirement.
Sorry, just to expand on that, but there are occasions when the crew will move passengers around the cabin to fly ABC, things like that, but they're very rare. It's good practice. It keeps the weight where it needs to be underneath the main rotor head. So on occasions there may be instances when that happens, but there's no requirement apart from, as Harry's alluded to already, the extra broads where they need to be sat near specific exits. No, very rarely.
Are all pilots fully aware of the relevant sections of CAP 437 which impacts on offshore safety?
Well, yes.
Yes.
Yes. Broadly speaking, yes.
Mm-hmm.
It's a core document, so we're all professional aviators, so we all take an interest.
What is the ratio of hours flown and hours of maintenance, roughly?
That varies. That varies quite a bit. It depends on the aircraft type. It depends on the time of year. Age of aircraft, like you say. So yeah, difficult to say. What I can say is all the aircraft have different maintenance cycles. So you have your daily maintenance on the aircraft. You got inspections every so many hours. There's a 400-hour inspection. There's a 1,200-hour inspection. There's a 1,500-hour inspection. At some points in their lives, the aircraft will be almost completely stripped to the bone and then put together again, just to make sure they are working as good as they were on day one.
Maybe one for you, Harry. How do you monitor the mental health of pilots?
we got a psychologist that works for us. We will have a peer support system in place, mandatory 14th of August next year, which will allow pilots to talk to other specially trained pilots about any mental well-being issues they would have. And that's part of it. Those peers will be monitored by aviation psychologists who are familiar with the field of aviation and who had special training in therapy and counselling.
I think it's worth mentioning as well that we have a yearly medical, and at that medical, is done by an aeromedical examiner, which is a doctor who's specifically qualified in aviation medicine. And although it's quite difficult in, say, an hour's consultation once a year, the doctors now actually will make a broad psychological assessment of you at that medical. So there is something already in place for that, although it is difficult because they're only getting a snapshot of you, during 1 hour of the year. But it is done already. But as Harry said, there's more regulation coming in next year.
Flying through a cloud causes a pitch change in the helicopter and gets a little bumpy. Am I right in assuming this is due to water vapour? And if so, what stops the water vapour entering the engine intakes?
There's nothing stopping the water entering the engine intakes, but the engines are built for that. If you remember some of the older racing cars, when they had the water injection to make the engine more efficient, it could work the same way for us, but there's absolutely no issue with the water vapor from clouds entering any engines. If it's heavier particles, they get pushed aside by the design of the engine intakes, so they are, unless they are as big as a bird, not likely to enter the engine.
What, if any, measures are in place to manage fatigue of pilots?
Lots.
Yeah. So and it would be seen by the clients and by you guys offshore when we say we don't have a crew available because they've run out of hours. So we have very set reporting times. We don't expect our crews to report any earlier than their set reporting time, and that forms the basis for their flying hours. Those flying hours are managed by all companies' in-house planning systems, so it gives a rough idea as to how many hours. It gives an exact idea as to how many hours those guys have available. And the crews are very good at self-policing. They know full well that they can fly a certain amount of hours. And quite often the case is if they've had a delay or the wind is not as planned, they'll come back and say to our operations department, I'm going to be very tight on this next rotation. I don't think I've got the flying hours to do it. And then they'll report it and we'll generally get another crew in to do that flight. But in terms of managing fatigue, we rely very much on us as chief pilots as a supervisory role, keeping an eye on them. The in-flight management of the planning system inside, again, the electronic version, but also our crews to look at each other and just ask each other, are you okay? Effectively, they're the best monitors and the best arbiters of whether or not they're fatigued. It is cumulative. We are flying a lot of hours, but again, we have a very much a put your hand in the air policy across all 4 companies where if there's any doubt, if you don't feel you're fit for the purpose and you are fatigued, report it, and there's always a solution.
Sorry, did you mention that? So the hours are regulated.
Apologies, yeah, sorry.
Cat 371. So the hours that we can fly in any given period, whether it's a year, 28 days, or even a week, are all regulated. But there are other fatigue risk management tools available as well.
More technology coming in, Dave. Yeah. So part of that electronic system is that there's more algorithms that will look, because it's not all to do with how much you're flying, it's to do with when you're flying as well. So and early starts you do, etc.
Questions coming. The helicopter safety has hugely improved over the last 10 years. 10 years ago, we wouldn't see every chief pilot sitting talking to each other. How much further do you think we have to go as an industry?
I don't think we ever stop.
Yeah. It's a continuing learning process. It's a continuing introduction of new technology. One of the things that is being looked at right now is live HUMS data. So this health and usage monitoring data of the helicopter, of where all the vibrations are, will in the future be transmitted live to an engineering station. That is not necessarily to warn the pilots, because there are warning systems inside the aircraft, but that allows the engineers to look during the flight at what maintenance might be needed going forward as soon as the aircraft lands.
There's lots of other technologies, lots of other studies have been done because the aircraft technology is changing. The aircraft that I first flew, which were very analog, old-fashioned aircraft, in the space of 15, 16 years have changed considerably. So the technology in the aircraft is changing. In each edition of aircraft that comes out, and each new aircraft that comes out has better safety systems, better hidden protections that will prevent us, because we are human, from doing something that we shouldn't. So that's always a continuous improvement. And that's why it's important that we keep innovating and we keep new aircraft coming to the industry basically.
There are a couple of questions on triggered lightning. Is triggered lightning affected by season, and if so, why don't you plan flights seasonally to be reminiscent of this?
I mean, the triggered lightning really only happens between October and March. It's due to an air mass that comes down from the polar regions. So we only really see it between October and March, although our seasons are shifting. We used to see the haar, the sea fog. I mean, you can pretty much guarantee in Aberdeen when you got to May, June, you'd see the haar, but now we're seeing the haar in July. So, climate change, we'll call it what we want, it is shifting, and we've seen the triggered lightning probably extend beyond March, depending on what kind of weather systems we're getting. We don't decide when you fly. It's your companies that decide when you fly, and they decide, what flights they want from us. So we don't really have an influence over when operators fly, we couldn't really write off the whole of the winter season. So that would be quite difficult. And then some seasons, we've seen since the triggered lightning product came in that we've seen very little of it, and then other years we've seen lots in very compact periods of time. So it would be very difficult to kind of schedule around it.
Aaron, it would be good. So we do less flying in the winter, then like you mentioned, the harm discover us in the summer. So very difficult to judge which phenomenon is going to affect us more every year.
Some helicopter types don't have full ice protection systems, so how do you plan flights in winter season with those types of helicopters?
You look at the clouds available, because those helicopters without the protection can still fly at low temperatures as long as they're not flying in the clouds and get icing on them. The other thing we look at is a limited icing clearance. So if you've got a positive air band of 1,000 feet and the aircraft can descend to shed ice or fly at that positive air band, then it's okay to use them as well.
Okay. How many different types of helicopters are there flown in the UK at the moment?
In oil and gas?
Yes, I presume so.
Yeah. Okay. So we've got, I suppose we'd have to go through them, wouldn't we? S92s.
192, 175, 189, 139, 76s still, 155s.
Somebody can know.
I am sort of running out of fingers.
6, 7.
Yeah.
I'd say probably we just want to miss by about 8. Probably about 8 times.
N3s.
Dauphins. Yeah.
Okay. What lessons learnt are suitable to share with the oil and gas industry if aviation have done really well with it, for example, fatigue, human factors?
So what could we share of what we know with oil and gas?
Mm-hmm.
I think there's probably quite a lot. I mean, we are one of the most regulated industries in the world, aviation is. And some of the stuff that Harry talked about in terms of crew resource management, safety systems, the way we do our day-to-day business can be related to a lot of other industries. For example, at my previous company, we did a lot of work with the NHS because there's a lot of similarities between what we do and what a surgeon does in a theatre. So there is a lot to be shared, and I'm sure there's a lot to be shared with oil and gas because it's a safety critical industry, and we're no different, and oil and gas is no different. Does that happen at the moment? I'm not sure. Probably not as much as it should. There is a huge untapped wealth of knowledge within our industry, which sometimes doesn't get transferred across. Say we are there's a lot of good knowledge in terms of safety critical systems.
Is this where step change in safety is fairly key in collaboration and communication? It's there, and I think we're moving along with it.
How, if at all, will Brexit affect helicopter safety in the UK?
Shall I answer that one as the person that's actually
It's
working for a European company?
But it's not going to affect safety.
I don't think
It's not going to affect safety
at all. No.
It won't affect safety. The issues aren't the word. There are certain changes that may happen if we fall out of Europe, which could affect our licensing, but it's not a safety issue. It's a bureaucratic issue. It really is just bureaucracy. And we didn't mention it, but in the brief, we are looked after at the moment by EASA, which is obviously a European organisation. And that's what people talk about with Brexit, is that if we fall out of that, what would that mean to us? But CA have already said that, for example, components that the UK have certified, so a component in an aircraft, they've already said, and the EASA have already agreed to that that certificate will last for 2 years. So we won't have to suddenly take out components. So if it was in our European aircraft, for example, my company, some of our aircraft are not on the UK register, we wouldn't suddenly have to remove those components. It still stands. And there's a huge amount of work going on in the background with the EASA to make sure that despite all the politics and the bureaucracy that the aviation world, and it's not just our little tiny bit here, I mean, it's global, continues as it is.
A question for pilots. Visual markings and obstacles sectors. Is there any formal training provided?
Yes, we have to sit through a yearly update on the visual markers on helidecks and all the requirements, the 5-in-1 sector, etc., etc.
Will any of the helicopter operators be starting an Air Miles accumulation award scheme? For the offshore workforce.
Where you get one free helicopter flight to a installation of your choice.
We let our executive club members sit in the forward seats.
Right.
We might be bringing back in flight catering whereby you'll get a boiled sweet. That'll be about it.
Will all the helicopter safety awareness courses be in Aberdeen?
I don't think so.
No, there's one in Norwich, as you may have seen in the beginning of the presentation.
What do you think about using a tilt rotor for oil rigs?
It's interesting, but you need to redesign the deck specifications probably, and especially the size of the decks, because the tilt rotors for the same volume of passengers are a little bit wider.
I think we've almost covered all the questions we've received in so far. Is there anything else you'd like to comment on as a panel?
For me.
Well, if that's all the questions sent in, I guess all that's left for us to say is thank you very much, esteemed panel, for your time. Thank you for all the listeners who've managed to step in. And please book on to the safety courses on the Step Change website, which is completely free for members.
Or get in touch
with us for information. Thank you very much.
Thank you.
Cheers, thank you.
Well.